As we talk about 5-3 step functions. When we talk about step functions, you're talking about going from one to the next, right? Usually there's no decimals in your answers, and the reason being is because you're stuck to a whole number at the end. I'll give you an example, okay? When we talk about buses, okay, let's talk about buses real quick. All right, let me pull up a whiteboard / Word document, okay? And this will talk about what we mean, or what I mean in particular, okay? Let's say, for example, you have 30 people per bus, okay? So 30 people will have one bus. So if you have 20 people, one bus. 29 people, also one bus. What do you have with 31 people? Well, that's too many people because that's more people than the buses that you need. So guess what? You need 2 buses. Okay, but we're going to draw this graph real quick. This is what we call a step function. Okay, the bottom represents the number of buses. Okay, or rather the number of people. Let me actually erase this. It's actually the number of people. Whoopsie doodles. Okay, so let's say 30, 60, 90, 120, 150, and then this represents the number of buses. Okay, so let's say if you have from 0 to 30 people, it's 1 bus. Okay, but if you get to 31 people, that's 2 buses. Then you get to 61 people, that's 3 buses. When you get to 120 people, that's 4 buses, and vice versa. This is what's called a step function. Okay, a step function means you're going from one number to the next, and then notice how they don't connect. Because the reason why they don't connect is because you're jumping to the next number essentially, okay? Without understanding that we're not finding slopes after the fact. Okay, let's go back to the textbook here. A step function like we talked about, it's kind of like you're stepping from one to the next, but they don't give you a decimal answer usually, okay? We talk about ceiling functions. Notice that little thing right there in the top. Let's just zoom in a little bit. Right there, okay? That means you are jumping to the next number by rounding it up. Okay, essentially, let's zoom out real quick. Boom. Okay, you're basically, there we go. Okay, you're rounding to the next number. So notice how 0.7 turns to 1, 1.8 turns to 2, 2.1 turns to 3. It's when there's a ceiling on the top. But when we talk about floor functions, essentially, floor functions you're rounding down. For example, 0.7 goes to 0. Even though it's closer to 1, it goes to 0. 1.8 goes to 1. 2.1 goes to 2, and vice versa. Okay, so here we go. Evaluate each function. Well, again, it's a ceiling. If you look at the marking on the top, it's a ceiling function there. So therefore, it goes to 3. Okay, this is a floor function. It's going to round down. It goes to 2. Not difficult. Okay, let's look at the next example here. Some students are planning a field trip. If there are 40 students and adults or fewer going on the trip, they need to rent vans. But if there's more than 40, they're going to rent buses. Okay, so from 0 to 40, it's going to be the number divided by 15 because that's for the vans. Greater than 40, it's going to be divided by 65 because we're talking about buses. So let's figure out 412 students. Well, it's more than 40, so we're going to divide that by 65. Since it's a decimal, bigger than 6, it goes to 7. Okay, let's erase this. Let's actually see what we mean for this part. Let me actually do this part here real quick. Okay, the postage for a first class weighing 1 ounce or less, 47 cents. Each additional ounce, 21 cents. So every ounce after that is 21 cents. So we have to make a function to represent this, okay? If it's less than an ounce, okay, 0.47, but this is a ceiling function, okay? So this is when x is less than 1. But then anything bigger than 1, you're adding 21 cents. So it's 0.47 plus 0.21, another ceiling function. And this is when x is greater than or equal to 1, essentially, okay? Again, since we're rounding it up, notice how we need to add 21 cents, 47 cents. Even if it's 0.1 ounce, it's still 47 cents, essentially. Okay, moving on. Last example. Jamal and his brother plan to rent a karaoke machine. Every hour, they're going to get charged Well, in the beginning, they get charged 30 bucks, but then every hour after that, they get charged 10 bucks, okay? As you write a function, boom, there you go, okay? So notice, actually, this should not be, this is a typo as a matter of fact. This should be 30, not 20. The reason why it's not 20 is because you're starting off with 30. So it should be 30, not 20. But remember, if you run it even for an extra minute, you're going to get charged for the second hour or the third hour or the fourth hour. So let's think about this, okay? You're in a karaoke machine at 1 o'clock. If you plan to return it by 4, you're going to save any money if you return it 15 minutes early? No, because in the third hour, you're still getting charged 50 bucks. So it doesn't matter. So this is no. Once you hit hour 3, so hour 3, you get charged 50 bucks. And this is no matter what. Okay, no matter what, you're gonna get charged 50 bucks. Okay, irregardless. So that'll do it here. That concludes the lesson. Enjoy. It's 5-3.